here are your notes on vectors. And so the last little piece we're going to cover in Math 112 is going to be on vectors. So in simple terms, a vector is a quantity that has both magnitude and direction. It is customary to represent a vector by using an arrow. The length of the arrow represents the magnitude. So magnitude meaning the length, so like how long, right? So maybe that would be miles. And then the arrowhead indicates the direction of the vector. So we will use this in this class. You will also use it in physics. It has a lot of applications, which is nice. So the first couple of videos is just going to walk us through the basic operations with vectors. So a characteristic of a vector is it has a initial point and a terminal point. Okay, and how you would name this vector is you always list your initial point first and then your terminal point. So this is one way to name a vector. You also put an arrowhead above the vector. So you could have an arrowhead that looks like this with two arrows, or I'm used to actually writing it with just one. So it looks like that. So there's lots of ways to name a vector. If you're going to use the initial and terminal point, once again, you always list your initial first and then your terminal. So this vector would be named PQ. All right, well, here are three vectors. And in this example, these are all equivalent. They're all equal. Even though they have different initial and terminal points, the reason they're equal is because the length of our vector, the magnitude, is the same. And they're all pointing in the same direction. So that makes them equal. Just so you realize there are other ways to represent vectors as well. So I could say, okay, well, PQ is 1. So I could have 2 arrowheads. I could also say PQ with just 1. That one I like better because this looks like an array, which is different than a vector. The other way is you could name it with one lowercase letter. So I'm just going to make this up and claim it as this vector V. And you could put an arrowhead above it. Or here's your other option is you can bold your vector V. Now, bolding something when we're handwriting is kind of challenging, right? We don't want to like drill a hole into our paper. So that's why most often when I'm writing, I'll probably use that notation. But in your book and in our notes, using this notation is easier than when we handwrite it. Okay, so that's just naming vectors. Now, operations with vectors, we can do all the operations with vectors. We can add them, we can subtract them, we can multiply them, we can multiply them by a scalar. We're going to talk about in the next section how to multiply 2 vectors, but right now we're just going to deal with multiplying a vector by a scalar, meaning multiplying it by 2 or 3. But one really important thing that we'll do is adding 2 vectors. Visually, you can do this by, and that's what this little paragraph is saying right here, is that you take your initial point of some vector V, okay, here's that vector. And if you wanted to add these vectors together visually, then you would place your initial point on top of your terminal point of the other vector and point that where it should go. And then what your resultant vector is, when you actually add them together, that's known as your resultant vector, is when you connect your initial point to the terminal point of the other vector. We aren't going to ask you to do that in this class. I'm just showing you visually what it would look like. We will be adding 2 vectors often, but we won't have to be doing it visually. So Another example is how we can name a vector in component form. So, this is named vector V, okay? And how we can do this in component form. So component form means you have the change of your x's, comma, the change in your y's. So what that means is, here's this, right? Well, I move to the right 1, 2, 3. So that will be 3 units to the right. And then from your initial to your terminal, how many did you move up? 1, 2. And so that's why it will be a positive 2. The other thing is with vectors, it gets these sideways V's. That's how I also know it's a vector. Do not use parentheses because that will make it look like a coordinate. So now looking at W, and again, I'm using that arrowhead because I don't want to bold anything. So again, start at your initial point. And what we do is we go from our initial to our terminal. So if I'm going from my initial to my terminal, I went 1, 2 down. So that's going to be represented as -2. And then from here to, again, I'm going to my terminal. I went 1, 2, but I went to the right. So that would be represented with a +2. Then you, all right, again, start at your initial. And then go, I'm going to have to go 1 to the right. So I'll represent that with a +1. And then I go up 1, 2, 3. Since I went up, it's a +3.